All right, good. Have a good day. This is Miss Triangle. I'm going to cross off the date. We are on 11.6, volume of pyramids. So our essential question, how do you find the volume of a pyramid? Our learning target, I can find the volume of pyramids, including similar figures and composite figures. And composite figures are, it's kind of like a compound word, like highway, is made up of high and way. A composite figure would maybe be like a house where you have a cube and a pyramid on top, and it's three-dimensional. So that's a composite figure. So what is the volume formula for a pyramid? So make sure you get your volume formula. Your formula is 1/3 base times height, 1/3 base times height. And just like we learned in section 11.6, B stands for the area of the base. Area of the base. So this is pretty similar to a prism or a cylinder. We're just adding the 1/3, and I think it kind of makes sense because instead of having two bases, like a prism, and it's sort of the same dimensions all the way up, a pyramid is getting narrower and narrower and ending in a vertex. So it's about 1/3 of the size of a prism. And I usually do a demonstration, and you can certainly find them on YouTube, and maybe I'll try to post one where they pour water into a pyramid, and they show that 3 pyramids worth of water, 3 volumes of a pyramid is equal to a prism. Anyway, get your formula down. That was what you need for that. All right, example problems. Number 1A, you have a triangular pyramid because the base is a triangle. So find the volume. Our formula is 1/3 base times height. I always start with big B, and I ask myself, what shape is my base? So my base is this little triangle right here. Yellow's kind of hard to see. We'll make it green. So the base is a triangle, So how do you find the area of a triangle? That is 1/2 base times height. Everything else should stay. So I have 2 H's, and I still have the 1/3 in front. A lot of people try to do everything in their calculator or at once. I would at least write it out. Otherwise, it's very easy to miss a 1/3 or the H at the end and get the wrong answer. All right, so we'll keep that. For the green part, the base and height of my triangle is 4/6. So 1/2 times 4 times 6. And if you want to go ahead and make that 12, you can go for it. This height is the height of the whole pyramid, which is 9. So you can plug this whole thing into your calculator. You can do it part by part. Really, it's up to you. And you should end up with 36 meters cubed. Remember, volume is always in cubic units. It's three-dimensional. All right, part B, a little bit more fun of a shape, if you will. This is a hexagonal pyramid, Still a pyramid. My volume formula is still 1/3 base times height. My base is a hexagon. The area formula for a hexagon is 1/2 A, little a stands for apothem, times P, the perimeter, apothem and perimeter. So if I look at my base, and maybe I'll do green again for the base, I can see that it's a regular hexagon because it has these marks. So each side is 12, and there are 6 sides, so 6 times 12. The perimeter is 72. Now, I do not know my apothem yet, so I need to find that. So you're going to have to think back to, I think it was section 11.3, where we kind of found the area of a polygon. And we're going to have to do that. So let's think about just the hexagon. 1, 2, 3, 4, 5, 6. And let's make a central angle and kind of make that triangle. So what do we know? We know that this is 12. And our goal here in doing all this work is to find the apothem. All right, that is our big goal, is to find the apothem. So let's start with our central angle. It is a hexagon, so let's take 360 degrees divided by 6. Whoops, not 60. Divided by 6 because it's a hexagon, and that gives us 60. So the central angle, that's this whole big part, is 60. So each side is 30 degrees. Okay, 30 degrees. And my goal is to find the apothem. I also know that this is 2 congruent triangles. So I can also make this a 6 and a 6 because 12 split into 2 is 6. Now you have several choices for finding your apothem. You could do tangent of 30 equals opposite, which is 6. Here's opposite, over adjacent, which is A, my apothem, and I could cross multiply and solve. I also could use like my knowledge of 30, 60, 90 triangles. If you kind of remember 30, 60, 90, those special right triangles where we had the reference triangle, we had x, 2x, and x squared of 3. We could use that since this is a 30, 60, 90 triangle. If we do that, the side across from 30 degrees is our x, so 6 is my x. The side across from 60 degrees is x squared of 3. So that would make my apothem 6 squared of 3. So it's up to you for what method you want to use. And you certainly can pause and rewatch that if you got a little bit lost. And the whole point of doing that was to find my apothem so I can find the area of the hexagon so that I can find the volume of the pyramid. So I can now find I can now find the area of the base of the hexagon. So area equals 1/2. My apothem, I'm just going to leave it as 6 squared of 3, so my answer is more precise. And the perimeter was 72. So I am going to plug all of that into my calculator. And I'm getting 374.12. 374.12. I hope that's right. Yes. All right. Then I'm going to now use, let's make it red, my volume formula. All right, I'm running out of room a little bit, so I'm going to come over here, 1/3 base times height. I still have the 1/3, that whole B, all that B, that was doing all that work up here. That was all that, 374.12, and the H, the height of my pyramid, is 20. So I can put that whole thing in. Don't forget the 1/3. It's up to you. You can type a fraction in. I usually type this in and then divide by 3, but you do you. And I'm getting 2,494.15 centimeters cubed. And again, the rounding, I'm going to understand the rounding, and I'll know, I'll understand if you get the process and you're a little bit off versus it's totally wrong. All right, let's move on to example 2. I think 1B, that was a tricky one, so definitely if you need to go back. So here, we're talking about the pyramids in Egypt. Well, there's also nice pyramids in Mexico too, but we're talking about Egyptian pyramids. So we have a height of 144 meters and a volume of 2,218,800 cubic meters. Find the side length of the square base. So you can't really see from this picture, but this is a square pyramid. So this is kind of what we have. I know it's a pyramid. I can see that. It's telling me that my volume formula is 1/3. Base times height. You always have the 1/3 in front if it's a pyramid. They are telling me my volume. My volume is that 2 million number. So that is going to go in here for V. Kind of my answer, and I'm working backwards. It's one of those types of problems. Let's keep the 1/3. We also know, what else do we know? We know the height. Height is 144. I'm going to keep B because I don't think I know anything about B, but I do know that the height, the H, is 144. Now, it's up to you how you want to do it. Personally, I usually, just to make the numbers a little easier, I kind of do 1/3 times 144 first, or do 144 divided by 3 just to make the numbers a little smaller. That's my personal preference. Not required. That gives me 48. Then I just solve my equation. I divide by 48, divide by 48. So it looks like B, big B, the area of the base is 46,225. Remember, big B is the area of the base. So that would be this whole thing. And the question asks for the side length, but we do know it's a square. Now, a lot of times people will want to divide by 4. That would be for perimeter. Think about it. If you knew that the area was 100, the square would be 10 by 10. How do you go from 100 to a 10? You take the square root. Square root. So I'm not dividing by 4. I'm taking the square root, and I am getting 215 meters for the length of one side. All right, we are